SpaceTime.
In physics, space-time is a mathematical model that combines the three dimensions of space and one dimension of time into a single four-dimensional manifold. Space-time diagrams can be used to visualize relativistic effects, such as why different observers perceive differently where and when events occur. Until the 20th century, it was assumed that the three-dimensional geometry of the universe, its spatial expression in terms of coordinates, distances, and directions, was independent of one-dimensional time.
The topic SpaceTime in overview. Mass, energy equivalence.
In physics, mass, energy equivalence is the relationship between mass and energy in a system's rest frame, where the two values differ only by a constant and the units of measurement. The principle is described by the physicist Albert Einstein's famous formula, E equals mc²2. The formula defines the energy E of a particle in its rest frame as the product of mass, m, with the speed of light squared, c2.
4-vector.
In special relativity, a 4-vector, or 4-vector, is an object with four components, which transform in a specific way under Lorentz transformations. Specifically, a 4-vector is an element of a four-dimensional vector space considered as a representation space of the standard representation of the Lorentz group, the 1/2, 1/2 representation.
The topic 4-vector in overview. SIC POVM.
A symmetric, informationally complete, positive operator valued measure, SIC POVM, is a special case of a generalized measurement on a Hilbert space, used in the field of quantum mechanics. A measurement of the prescribed form satisfies certain defining qualities that makes it an interesting candidate for a standard quantum measurement, utilized in the study of foundational quantum mechanics, most notably in cubism.
Energy, momentum relation.
In physics, the energy-momentum relation, or relativistic dispersion relation, is the relativistic equation relating total energy, which is also called relativistic energy, to invariant mass, which is also called rest mass, and momentum.
The topic energy, momentum relation in overview. Energy.
In physics, energy, from ancient Greek, neuro gamma epsilon iota alpha, energia, activity, is the quantitative property that is transferred to a body or to a physical system, recognizable in the performance of work and in the form of heat and light.
Matter.
In classical physics and general chemistry, matter is any substance that has mass and takes up space by having volume. All everyday objects that can be touched are ultimately composed of atoms, which are made up of interacting subatomic particles, and in everyday as well as scientific usage, matter generally includes atoms and anything made up of them, and any particles, or combination of particles, that act as if they have both rest mass and volume.
4 velocity.
In physics, in particular in special relativity and general relativity, a 4 velocity is a 4-vector in 4-dimensional space-time that represents the relativistic counterpart of velocity, which is a 3-dimensional vector in space. Physical events correspond to mathematical points in time and space, the set of all of them together forming a mathematical model of physical 4-dimensional space-time.
Theory of relativity.
The theory of relativity usually encompasses two interrelated theories by Albert Einstein, special relativity and general relativity, proposed and published in 1905 and 1915, respectively. Special relativity applies to all physical phenomena in the absence of gravity.
Electromagnetism.
Electromagnetism is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields, and it is responsible for electromagnetic radiation such as light.
The topic electromagnetism in overview. Maxwell's equations.
Maxwell's equations, or Maxwell-Heaviside equations, are a set of coupled partial differential equations that, together with the Lorentz force law, form the foundation of classical electromagnetism, classical optics, and electric circuits.
Time evolution.
Time evolution is the change of state brought about by the passage of time, applicable to systems with internal state, also called stateful systems. In this formulation, time is not required to be a continuous parameter, but may be discrete or even finite.
Linearized gravity.
In the theory of general relativity, linearized gravity is the application of perturbation theory to the metric tensor that describes the geometry of space-time. As a consequence, linearized gravity is an effective method for modeling the effects of gravity when the gravitational field is weak.
Radiation.
In physics, radiation is the emission or transmission of energy in the form of waves or particles through space or through a material medium. This includes
Albert Einstein.
Albert Einstein, E.Y.E. Einstein, German, Albert Anton, listen, March 14, 1879 to April 18, 1955, was a German-born theoretical physicist, widely acknowledged to be one of the greatest and most influential physicists of all time.
Four-dimensional space.
A four-dimensional space, 4D, is a mathematical extension of the concept of three-dimensional or 3D space. Three-dimensional space is the simplest possible abstraction of the observation that one only needs three numbers, called dimensions, to describe the sizes or locations of objects in the everyday world.
General relativity.
General relativity, also known as the general theory of relativity and Einstein's theory of gravity, is the geometric theory of gravitation published by Albert Einstein in 1915 and is the current description of gravitation in modern physics.
The topic general relativity in overview. Quantum gravity.
Quantum gravity, QG, is a field of theoretical physics that seeks to describe gravity according to the principles of quantum mechanics, and where quantum effects cannot be ignored, such as in the vicinity of black holes or similar compact astrophysical objects, and where the effects of gravity are strong, such as neutron stars. Three of the four fundamental forces of physics are described within the framework of quantum mechanics and quantum field theory.
Quantum field theory in curved space-time.
In theoretical physics, quantum field theory in curved space-time, QFTCS, is an extension of quantum field theory from Minkowski spacetime to a general curved spacetime. This theory treats spacetime as a fixed, classical background, while giving a quantum mechanical description of the matter and energy propagating through that spacetime.
Manifold.
In mathematics, a manifold is a topological space that locally resembles Euclidean space near each point. More precisely, an n-dimensional manifold, or n-manifold for short, is a topological space with the property that each point has a neighborhood that is homeomorphic to an open subset of n-dimensional Euclidean space. One-dimensional manifolds include lines and circles, but not lemniscates.
Astrophysics.
Astrophysics is a science that employs the methods and principles of physics and chemistry in the study of astronomical objects and phenomena. As one of the founders of the discipline said, astrophysics seeks to ascertain the nature of the heavenly bodies, rather than their positions or motions in space, what they are, rather than where they are. Among the subjects studied are the Sun, other stars, galaxies, extrasolar planets, the interstellar medium and the cosmic microwave background.
Gravity.
In physics, gravity, from Latin gravitas weight, is a fundamental interaction which causes mutual attraction between all things with mass or energy. Gravity is by far the weakest of the four fundamental interactions, approximately 1038 times weaker than the strong interaction, 1036 times weaker than the electromagnetic force and 1029 times weaker than the weak interaction.
Dimension.
In physics and mathematics, the dimension of a mathematical space, or object, is informally defined as the minimum number of coordinates needed to specify any point within it. Thus, a line has a dimension of 1D, because only one coordinate is needed to specify a point on it, for example, the point at 5 on a number line.
Minkowski space.
In mathematical physics, Minkowski space, or Minkowski spacetime, is a combination of three-dimensional Euclidean space and time into a four-dimensional manifold where the space-time interval between any two events is independent of the inertial frame of reference in which they are recorded.
The topic Minkowski space in overview. Euclidean space.
Euclidean space is the fundamental space of geometry, intended to represent physical space. Originally, that is, in Euclid's Elements, it was the three-dimensional space of Euclidean geometry, but in modern mathematics there are Euclidean spaces of any positive integer dimension, including the three-dimensional space and the Euclidean plane, dimension 2.
Causal structure.
In mathematical physics, the causal structure of a Lorentzian manifold describes the causal relationships between points in the manifold.
Degenerate matter.
Degenerate matter is a highly dense state of fermionic matter in which the Pauli exclusion principle exerts significant pressure in addition to, or in lieu of, thermal pressure. The description applies to matter composed of electrons, protons, neutrons, or other fermions.
Pseudo-Riemannian manifold.
In differential geometry, a pseudo-Riemannian manifold, also called a semi-Riemannian manifold, is a differentiable manifold with a metric tensor that is everywhere non-degenerate. This is a generalization of a Riemannian manifold in which the requirement of positive definiteness is relaxed.
Quantum.
In physics, a quantum, plural quanta, is the minimum amount of any physical entity, physical property, involved in an interaction. The fundamental notion that a physical property can be quantized is referred to as the hypothesis of quantization.
The topic quantum in overview. Covariant derivative.
In mathematics, the covariant derivative is a way of specifying a derivative along tangent vectors of a manifold. Alternatively, the covariant derivative is a way of introducing and working with a connection on a manifold by means of a differential operator, to be contrasted with the approach given by a principal connection on the frame bundle. See affine connection.
Photon.
A photon, from ancient Greek phi omega tau, phos, photos, light, is an elementary particle that is a quantum of the electromagnetic field, including electromagnetic radiation such as light and radio waves, and the force carrier for the electromagnetic force.
Astronomy.
Astronomy, from ancient Greek sigma tau rho omicron nu omicron mu alpha, astronomia, science that studies the laws of the stars, is a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origin and evolution.
The topic astronomy in overview. Gamma ray.
A gamma ray, also known as gamma radiation, symbol gamma or gamma \display style \gamma.
Cosmology.
Cosmology, from ancient Greek kappa sigma mu omicron, cosmos, world, and dash lambda omicron gamma alpha, logia, study of, is a branch of physics and metaphysics dealing with the nature of the universe. The term cosmology was first used in English in 1656 in Thomas Blunt's Glossographia, and in 1731 taken up in Latin by German philosopher Christian Wolff, in Cosmologia Generalis.
Astrometry.
Astrometry is a branch of astronomy that involves precise measurements of the positions and movements of stars and other celestial bodies. It provides the kinematics and physical origin of the solar system and our galaxy, the Milky Way. The history of astrometry is linked to the history of star catalogs, which gave astronomers reference points for objects in the sky so they could track their movements.